Bonjour. This lesson focuses on a correlation coefficient that we call Spearman rank correlation coefficient. It is a complement of the lesson on the correlation where we have studied the Pearson correlation coefficient. This lesson lasts about 15 minutes. As we will follow the same demonstrations and use the same example, it is necessary to have listened to the course on correlation before. At the end of this presentation, we will use the student t-test. You can see how to use it in the lecture on the comparison between two means. We took the example of the study on the correlation between two laboratory techniques that were applied on a series of 30 sera. The results of Technique 1 were expressed in units which ranged from about 9 to 51, as the results of Technique 2 ranged between 0.10 to 0.50. And then we have plotted the cloud of points where the results of the Technique 1 are on the x-axis and the results of the Technique 2 on the y-axis. But now we will look not to the values themselves, but to their position in the set of values. Thus, we must replace in the list each value by their rank. It's a very boring activity to rank values, but fortunately Excel will help us to do that. For those who don't know the function rank in Excel, let us have a look at this little example. To rank these 10 values listed in column A, you have just to enter in any cell of the spreadsheet the function equal rank and between brackets the name of the first cell to classify, here A1, comma, the set of values $A, $10, and after a comma, the argument 1, which indicates an ascending sorting. I wrote below the command for those who use a French version of Excel. Then we obtain the number 2, which indicates that the value 21 is the second of the series. We continue the same operation for each value of the series. Here one can see that the value 43 is the seventh of the series. And finally, by dragging down the fill handle, we get the entire list of the 10 ranks. You notice that Excel has decided to give the fourth rank to the value 28 and then to jump directly to the sixth rank. We will examine further this problem. Go back to our example. On the left table we have the results values of the two techniques, and on the right table we have now the ranks of the values among the 30 sera for each technique. Among the results of the Technique 1, the value 40 is the 23rd. Among the results of Technique 2, the value 0.37 is the 21st. And now we can draw the cloud of points representing the couples of the ranks. It is similar to the previous cloud, but now, instead of the values, the axis units are the ranks, which range from 1 to 30. And similarly, it is possible to draw the least squares line and get directly with PowerPoint or Excel its parameters, slope and intercept. And now here is the formula of the Spearman rank correlation coefficient that we call RS. It is not so complicated. At the numerator, the term sum of x minus y squared means the sum of the squared differences between the ranks for each result. And at the denominator, n represents the number of couples. Let us apply this formula to our example. We begin to calculate the squares of the differences between rank values. At the first line, 23 minus 21 make 2, whose square is 4. We calculate now the sum of these squares, 1840. And after applying the formula, we found a RS value of 0.81. You can calculate this coefficient more easily with Excel. You have just to apply the correlation function correl to the set of the rank values instead to the set of the values themselves, as we did for the Pearson coefficient. One obtains directly the Spearman coefficient. I would like to come back on a little problem with Excel when there are equal values. In my previous example, I did not take equal values. As we saw it before, the rank function of Excel gives the lower rank to the equal values. Here, Excel gives the rank 13 to the two values 120. But most of the softwares, like Stata, prefer averaging the ranks of the equal values. Here, instead of 13, they would attribute to the two equal values the rank 13.5, which is the mean of the 13th and of the 14th rank. Then we pass directly to the rank 15. Thus, be careful with that problem of equal values when you calculate a Spearman coefficient with Excel. Don't forget to correct the set of the ranks. A Spearman coefficient is interpreted exactly as a Pearson coefficient. It ranges between -1 and +1. More the coefficient is close to 1 or close to -1, stronger is the correlation. More the coefficient is close to 0, weaker is the correlation. The last step is how to verify if a Spearman coefficient is significantly far from 0. For that, we have to use a statistical test. As for the Pearson coefficient, we begin by making hypothesis. H0, the theoretic coefficient ρ, is supposed to be null. The cloud of points is completely scattered. H1, the theoretic coefficient ρ, is supposed to be different from 0. In our example, we found a coefficient of 0.81. Is this value of 0.81 far enough from 0 so that we can reject H0? One demonstrates that the distance of the Spearman coefficient to 0 divided by its standard deviation follows the student law. Then, if H0 is true, the t-value is close to 0. Then how to calculate the standard deviation of RS? One demonstrates that the standard deviation of RS is equal to the square root of 1 minus RS squared divided by n minus 2, where n is the number of couples of values. Here is the complete formula of the statistic t, which follows a student law with the n minus 2 degrees of freedom. And if t is greater than the critical value t5%, with n minus 2 degrees of freedom, then H0 would be rejected. Now let's calculate the t-statistic with the data of our example. We have RS equal to 0.81, n equal to 30. We calculate the standard deviation of R, square root of 1 minus 0.81 squared divided by 28, that gives 0.11. We calculate t, 0.81 divided by 0.11, that gives 7.4, with 28 degrees of freedom. This value of 7.4 is largely greater than the critical value T5%, which is 2.05 with 28 degrees of freedom. It is still greater than 6.22, that corresponds to a risk error lower than 10 power minus 6, which gives us the p-value. If you don't want to make these calculations, I show you here the syntax of Stata software, which is very simple. One writes the word Spearman, followed by the names of both variables, here take1 and take2. And one obtains directly the Spearman coefficient, here 0.81, and the p-value, which is lower than 0.000 and so on. Thus, the conclusion of our example is there is a strong and significant correlation between the results of the two techniques. At the end of this analysis, we obtain two parameters. First, the correlation coefficient, R, which gives the strength of the correlation, here 0.81. And a second parameter, the p-value, which gives us the significance level of the test. These two parameters have a very different meaning. For example, it is possible to observe a strong correlation but not significant when the power of the analysis is weak because the sample size is too small. On the opposite, it is possible to observe significant but too weak correlation to be of interest. What are the conditions and the limitations for using a Spearman test? First, the variables x and y must be random variables and independent. Third, the number of couples of values must not be too small. An amount of 10 couples of values is a minimum. Then, it is better to have not too much equal values in each set of data. Finally, you notice that unlike the correlation analysis, there is no assumption about normality and homoscedasticity. That is the great advantage of the rank correlation when there is some doubts about these conditions. Then, to finish with the correlation, what coefficient should we choose? Pearson coefficient or Spearman coefficient? First of all, you have noticed we obtain two similar correlation coefficients. But the statistical analysis of the Spearman correlation coefficient have permitted to avoid the drastic conditions of normality and homoscedasticity. Despite this advantage, the Spearman coefficient correlation is not yet commonly used because of the historical difficulty of manually rank values. Obviously, now this operation is made immediately with the softwares and spreadsheet. Thus, if there is not too much equal values, there is no reason not to use the Spearman rank correlation coefficient. Here is a small example to show you the danger of the use of the Pearson correlation when the conditions of normality are not met. On this graph, you see a cloud of points which are obviously not correlated except two outliers. But because these outliers have a heavy weight in the calculation, the Pearson coefficient is high and the test is highly significant. And a conclusion which would assert a strong and significant correlation without taking into account the lack of normality of the values would be wrong. If we choose a Spearman rank test, which simply attributes the two last ranks to the outliers, we obtain a completely scattered cloud and the calculations shows a lack of correlation, which is the true situation. In such a case, where the conditions of normality are not present, it is clear that the Spearman rank coefficient should be used instead of the Pearson coefficient. And to finish, I would conclude, as in the previous lecture on the correlation, by a mention about causality. Remember that correlation, as strong it could be, as significant it could be, is not at all the proof of a causal relation. For example, there is a very strong correlation between sales of ice creams on the beach in the summer and the occurrence of sunburns. Is the ice cream consumption the cause of sunburn? I leave you with this very serious question and I tell you, à bientôt!